Welcome back to the deep dive. So, if you've been following the world of AI, even casually, you've probably heard a bunch of terms flying around.
Oh, yeah.
Things like generative AI, AI agents, and agentic AI. They seem to be
They
everywhere.
really are.
And, well, if you're like me, you might be wondering, are they all just fancy ways of saying the same thing? Or is there, a real difference?
That's a great question. There definitely is.
Okay, let's unpack this then. Our mission today is really to cut through that noise, dig into the core differences between these, well, three really vital concepts in AI, using all the great stuff we've gathered for this deep dive.
Yeah, and it's more than just clearing up jargon, I think, understanding these distinctions. It's actually
Absolutely.
vital for anyone really engaging with AI right now,
Hmm.
whether you're just, curious, trying to figure out what's next, or maybe you're a professional looking at how to use these systems.
Right.
Knowing the difference between what an AI can generate, what it can do specifically, and how it can collaborate. Yeah. It really changes how you see the potential.
That's spot on. So let's start with the one maybe most people have bumped into, generative AI. This feels like the foundation for so much of what's happening.
Definitely. It's the bedrock.
Can you kind of set the stage? What's its core function, basically?
Sure. So at its heart, generative AI refers to these models, mostly large language models, LLMs, or large image models, LMs.
Okay.
And these things are massive,
Hmm.
truly colossal neural networks. We're talking billions of parameters.
Billions.
Yeah,
Okay.
think of parameters like all the tiny adjustments and connections they learn. And they're trained on just enormous amounts of data,
Yeah.
huge data sets.
Okay, so big models, lots of data. What do they actually do?
Right. Their defining function is to create new content. That's the
Good
key.
content.
Yeah, and our sources point out this isn't just like text. It can be brand new images, original writing, single video frames, audio tracks, even whole videos. The main thing is they don't just repeat information back. They synthesize, they create something novel.
And we've probably all used these, right? Like Llama 3 or OpenAI's models like GPT-4, GPT-4 Mini. Those are generative AI.
Exactly. Those are classic examples. And a really crucial property of these applications is that they're reactive,
Reactive, meaning.
meaning they need you, the user,
Mhm.
to give them specific prompts or instructions to actually generate anything.
Oh.
They don't just, wake up and decide to write a poem. They wait for your input.
So it's that prompt idea we hear so much about. Like you give it a specific sentence, tell it how to behave, maybe act as a data scientist and interview me.
Precisely that. That's the trigger. That instruction tells it how to generate the response you want.
Gotcha.
And, behind the scenes, developers building apps with these models use tools, libraries like LangGraph, LangChain, Llama Index, or a code from Grok,
Right.
OpenAI.
About the plumbing.
Yeah, exactly. Those frameworks help us talk to and guide these generative models effectively.
Okay, so that's generative AI creates new stuff when you prompt it. But for all that power, they hit a wall pretty quick, didn't they? This is where it gets really interesting.
It really is. The big disadvantage of a standalone LLM, just the model itself,
Mhm.
is it often doesn't have current information.
Right. Like, ask it about today's news.
Exactly. It probably won't know
Mm.
because they typically aren't connected live to the internet. And they certainly don't have access to, say, your private company data unless someone specifically trained it that way, which is
Uh,
not standard.
okay, so that's a major limitation.
Huge, but this is where tool calls come in. It's a really clever solution.
Tool calls.
Yeah. So when an LLM gets a question, it can't answer from its training data. Maybe it needs live info or needs to use another service. It can actually look for external things,
External thing.
like third-party APIs, different data sources.
Tools, basically. And our sources had that great example. If I ask an LLM, hey, what is the news for today? A basic generative AI model is stuck.
Stuck. Correct. But with tool calls, the process is fascinating.
Hmm.
First, the LLM recognizes, okay, I don't know this.
Mm-hmm.
Then it makes a tool call to something external, maybe an internet search tool like Tavily, which our sources mention.
Okay, so it reaches out.
It reaches out.
Wow.
It gets a response back from that tool, maybe a whole load of search results or data. Then the LLM uses its intelligence to process and summarize that output to give you the actual answer you wanted, like the day's headlines.
Wow, okay, so that's much more active.
Exactly. So
Yeah.
putting a definition on it,
Mm-hmm.
an AI agent is specifically designed to solve a single specific task,
One task.
one task. And it does this using an LLM's power, but, and this is key, it extends that power by making these tool calls to interact with the outside world.
That makes it really clear. So generative AI generates. AI agents solve a specific task by using the LLM plus those tool calls to get outside help.
You got it. It gives the LLM ways to interact beyond its own knowledge.
It's not just a brain anymore. It's a brain that can, like, pick up a phone or use a search engine.
Reput.
Yes. Okay, so if an AI agent handles one task, what about really complex problems? Things with lots of steps.
That brings us to the next level, right? Agentic AI. This is where things seem to get really powerful.
This is exactly where agentic AI comes in. It's a step up in complexity. Agentic AI isn't just one agent, it's a whole system.
A system.
Yeah, a system where multiple specialized AI agents are actively collaborating with each other.
Collaborating like a team.
Pretty much. They work together to solve an entire complex workflow to achieve some larger overall goal.
Okay, I need an example. Our sources mentioned converting a YouTube video to a blog post. That sounds complicated.
It's a perfect example because it's not just one action. Think about the steps involved.
Okay.
First, you need the words, right? So task 1, take the transcript from the YT video.
Right.
Then task 2, you need a good title. Create and title. Task 3, creating description. Maybe task 4, writing the conclusion.
Okay, so multiple distinct steps. Exactly.
Yeah.
And in an agentic AI system, you'd assign different AI agents to each of these subtasks. You might have, say, AI agent 1 for the transcript.
The transcript agent.
Yeah, then AI agent 2, the title agent, AI agent 3, description agent, AI agent 4, conclusion agent.
Yep.
Each one has a specialist.
Ah, I see. So you have a team of specialist agents.
You do.
Yeah.
And here's a crucial part of the collaboration you mentioned. They aren't just working alone in bubbles.
They talk to each other.
They have to. Agent 1 finishes the transcript and passes it to Agent 2, 3, and 4.
Yeah.
Agent 2 creates the title, maybe passes that along too. They communicate, share their outputs.
So they build on each other's work.
Precisely. They pass the necessary information between them to achieve that final goal, the complete, coherent blog post.
That's really cool. So the big difference is...
The core difference is a single AI agent does just one specific task, maybe using a tool. But in an agentic AI system, you have multiple AI agents collaborating, interacting, working together to solve a much bigger multi-step goal.
Like a workflow.
Exactly, an entire workflow. And what's also powerful is you can often build in points for huge feedback within that workflow. So a person can check things or make adjustments.
Okay, wow. That paints a really clear picture. So just to quickly recap this deep dive.
Yeah, let's nail it down.
Generative AI, that's the engine, creates new content, text, images, whatever, based on prompts. It's
Right.
reactive.
The creator.
Then AI agents, they take that LLM power, add tool calls, and focus on solving one specific task by reaching out for external info or actions.
The single task solver.
And finally, agentic AI. That's the team coordinator. It orchestrates multiple AI agents, having them collaborate and communicate to tackle a whole complex workflow and reach a big goal.
The collaborative system.
Incredible.
And what's truly fascinating here, I think, is seeing this evolution. We're moving from just generating stuff to, well, sophisticated problem solving and teamwork between AIs. This path, from just writing text to managing these multi-step operations that almost mimic how human teams work, it shows the huge potential for agentic AI to automate really complex stuff.
Across all sorts of areas.
Pretty much any domain you can think of, yeah. The potential for handling intricate challenges is just immense.
It really does blow things wide open. So for you, our listener, here's maybe a final thought to chew on.
Ooh, I like this.
Think about a complex project you're working on. Could be work, could be personal. Try to break it down like we just did with the blog post. How many distinct tasks, like individual AI agents, can you spot inside that project?
Interesting exercise.
And then what might an agentic AI system look like if it was designed to help you reach the ultimate goal for that specific project? Seeing it that way, what new ideas or, I don't know, possibilities does that spark for you?